Hello everyone, this is Puya. So in this lecture, we're gonna focus on file input output from CPP files. So just gonna focus on the text file input output. This is a review from CMPT 135 course. So we have streams in C++, which are like you're already used to one kind of a stream, which is output a stream, input a stream using cout and cin. Streams are special objects that deliver program input and output to or from your program. So it basically provides an interface between your program and something external. So for example, cout would provide an interface between your program and your output console. A stream can be thought of as a flow of characters. So like something that like a string, like that would just go from your program into like an external object, which can be the console or it can be a file. Or it can just like flow from your keyboard into your program or from a file into your program. An input stream flows into your program, can come from keyboard like cin, or can come from file, which is what we discussed today. An output stream flows out of your program, can go to your screen, the output console, using cout or cr, and either also like can go to a file, a text file, for example. So think of these two operators. I call it insertion operator as an operator to move data from your program to an output stream. So in that case, it's the monitor. So like when you use the insertion operator, you're just basically inserting something from your program into an output stream. And think of extraction operator as an operator to move data from an input stream into your program. So for example, cin would move data from the keyboard into your program. Now what we will be discussing today, instead of like flowing data to monitor or from keyboard, we're just gonna see how to flow this into a file or flow it from a file into our program. Cin reads a sequence of ASCII characters from input keyboard and converts given values to internal format. So like whatever you read from the keyboard, it's going to be converted into internal format and you can use it in your program when you read something from the user. Cout does the opposite, converts internal values to ASCII text and display it on the monitor or export it to a file. The programmer can create other streams. So you've already seen cout and cin that are available in the standard library and using namespace standard. iOS stream library and namespace standard. So streams can flow into a file as well. We can have multiple streams, each flowing into their own file. So like we can have multiple files opened and we can read from a file, write another file, and like read from another like third file, and so on. Streams can also flow out of files, can have multiple streams, each flowing outside of its own file. Programmer created streams can be used like C++ predefined streams such as cin or cout. So this is basically what like the model that we're gonna see today. We're just gonna have a text file and we're gonna read data from it into our program. Instead of like using cin, we can read from a file, or we can export data from our program into a text file. Okay, so that's what a stream basically does. So far we've only been working with console input, keyboard, and output screen streams. This was achieved with the library IO stream input output stream directive, and like you just like include this directive on top of your program and use the namespace std in where the cout and cin objects are instantiated. In addition to console input output, we have C++ supported file input output streams. So if you include another library called fstream, F is short for file. If you include this directive in your program, you can also support file input output streams in your C++ file. Streaming objects are basically special objects in C++ that deliver inputs to our program or deliver output from our program. As an example, cout is an object, an output streaming object, while cin is an input streaming object. So there's a class defined in the IOStream library, and cout is an instance of that class, and cin is an instance of another class. And basically they provide streaming from your file into a file, from your program into a file, or from a file into your program. These objects require special operators, which you'll see here, insertion and extraction operators. These are streaming operators in order to direct input and output towards the file or from the file. In order to work with file input output streaming operators, we need C++ streaming objects that get connected to physical files in the hard drive of computer. So we have a physical text file, and it has a name, it has a physical name. So we have to connect that name into a name into a name in our program. So that's what we have to do. Each file is supposed to have a connection between the physical name, physical file, and the name that we give it into in our program. The file input output streaming objects are defined in the standard namespace inside the fstream include directive. So we can use either fstream. The fstream can be used for both input and output, or you can use ifstream, which is for input, or ofstream, which is solely for output. Therefore, we need to include the fstream directive and also use the namespace standard. Once file input or output object is defined, it is used exactly as cout and cin objects together with the insertion and extraction operator, streaming operators. So this program shows how to write a text file. It's a very simple example. So you can see here we have included the IOStream library. We have also included the fstream and a string library, and we use the namespace standard. So these three lines can be written in many different ways. Like in future examples, you will see like other ways of writing, other ways of instantiating this object. So fstream is the name of a class, right? So here we're instantiating an object of this class. We call it outFile. Okay, this is the name of the object that we associate with the file in our program. Our file in our system has a physical name. So in this case, it's called test.txt. But in our program, we associate that name with an object name, in this case, out file. So because we use the fstream class in this case, this can be used as input or output. So we have to specify which one we want to use it as. We want to use it as input or we want to use it as output. So here you have the name of the file. This is the real name, the physical name of the file that you store it in a string object called out file name. Okay, so now we want to make this connection between this object and this file. So how we do it? We do it using the open member function of the class fstream. So in this case, you say outFile dot open, and you provide the name of the text file that you want to write to. So outFile is the name of the object, and here you provide the name of the text file. In this special format, when we're using fstream, we have to specify we want to read into our read from the file, or we want to write onto the file. Because we want to write a text file, so we have to provide the iOS. This is like a member variable, like a static member variable of the class. So we have to provide this into the open member function. So we have to provide iOS : out. So here, like, we made the connection between this object name and this actual physical name of the file. Okay, so we basically instantiated an object of class fstream, and we associated that file, that object, with the name of the file. Okay, as mentioned earlier, these three lines can be written in many different ways. This is just one way of writing it. On the next examples, you'll see other ways. For many reasons, this operation can be unsuccessful. So let's say you don't have any memory, you make a typo, so like for many cases, in this case because we were writing, so like you might just like don't have any space in your memory to create a new file. You might be in a write protected folder, so this operation might be unsuccessful. So here we can check if this operation was successful or not successful. So here we just like say if outFile dot is open. This is name of another member function of class fstream. So this is either going to be true or false. If it's true, it means that we could create a text file named test.txt, and we associated this text file with this object. Now, if we want to write anything on this text file now, you can just like, it's going to be the same, like very similar to the format of cout. So you just basically stream this string into the file, stream another integer into the file, and whenever you're done, you have to disconnect this object and this text file. Otherwise you might have problem opening that text file or like writing other things on that text file. So you have to close it. When you open it, you always have to close it when you're done. One thing I forgot to mention here is that when you're writing a text file, so if this file doesn't exist, if we don't have a text file with the name test.txt in the folder of C++ already, in the folder of our C++ program already, this is going to be created. This text file is going to be created. If this text file already exists in the folder that is in the working folder of our C++ program, then it's going to be overwritten. Okay, so we have to be very careful. If you're not careful, like, you might lose the previous value that was the previous content of this text file. So once this operation is done, we created the text file, we wrote something in it, and we disconnect this text file from the out file fstream. And if the opening operation was not successful, we just provide a message on the screen for the user that we could not create the file. Okay, so this is a very simple example of writing a text file. So I have a question from you guys here. What function do you think it's called here in this line? So this is creating an object of this class. So this is gonna call the default constructor of class fstream to instantiate this object out file. Okay, and then later on we use the open member function of that class to make a connection between out file and test.txt and open this text file. Okay, again, this is only needed if you're using the fstream class, because fstream can be used for both input and output. So whenever you open a file, you have to specify if you're opening it for writing or reading, for input or output. In this case, it was output, so we had to provide ios : out. So in order to create an output file streaming object, we construct, so that's why, like I said, default constructor, we construct an object of type ofstream. Okay, so in addition to class fstream, we also have data type ofstream or ifstream. Ofstream is only used for outputting from your program into a file. ifstream is used to read a file into your program. So in this case, we can use ofstream fout. Again, we are using the default constructor to create an object of class ofstream. And once a file output a streaming object is constructed, we can connect it to a file as follows: fout.open. This is the name of the file. Okay, so this is gonna be how we create a connection between the fout and the physical file that we want to either create or overwrite. Pay attention here. Now that we use ofstream, you don't need to provide that ios : out anymore. Okay, so if you're using ofstream, we know that we want to write onto that file, so it's not needed to provide that ios : out. And as mentioned here, this class provides a constructor. This is a default constructor that instantiates this object. Now, these two lines that we see here can be merged together, into one line. So we don't need to open it if we use the non-default constructor of this class. Okay, so construction of output file streaming object and connect it to a file can be done together in one C++ statement as follows. So in this case, you're instantiating an object of class ofstream. We name it fout, and this is gonna open the text file either for writing or overwriting on it. So in this case, you don't need to open it anymore, right? This is already implicitly done in the non-default constructor, and we don't need to worry about that. When we connect output file streaming object to a file in the hard drive, the file will be created automatically. So as soon as you do that, a text file will be created in the folder of your C++ file. If the same file name already exists, it will be overwritten. So it will be deleted, and the new data that you want to write onto it, it's gonna replace the previous content of it. So you just like have to be very careful to use OFS stream. So like this is like what I just explained in Visual C++. The file will be created in the folder where the CPP file of our project is located. If you want to create your file in a different folder, you have to provide the path of the file here before the name of the file. We're going to see this later, but I'm going to mention it as we are here. So your file will be automatically created in the same folder of your C++ file. In other compilers, it might be different. But if you wanna like create your file in a different folder, you have to provide the path of it here. So like for example, cc colon / the name of the folder and etc. Once the output file streaming object is created, it will be used together with the insertion output stream operator. So we can call this one now output stream operator, in exactly the same way that we use cout with this. For cout, the output goes to the screen, while for the streaming object, the output goes to the specified file. Okay, so this would just provide like an output to something. It can be like if you use it with cout, it would display it on the screen. If you use it with the file streaming object, it would stream it into a file. This is very important that once we have finished using an output file streaming object, we need to close it. So as we opened it, we have to close it when we are done with it and disconnect the output file streaming object from the physical file in the hard drive. This is done using the close member function. So when you say fout.close, it would just basically make a disconnection between that object and the text file. Once an output file stream object is closed, it can no more be used, so it cannot be changed anymore unless it is opened again. So you can open a file, close it, you can open it again, and you can close it. So you can open and close a file multiple times within the same program. So this is just an example from Dr. Yunus. You can see here we are using the fstream library. So when you include the disk directive, you can use both ifstream and fstream classes as well, so that those are defined here. So ofstream fout, so like using non-default constructor to make a connection between this object and this file. We are writing these two strings into the file and then we close it. As simple as that. So a file named example output file will be created in your C++ folder. These two strings will be appearing in the file. Like we said earlier, when we open an output file stream object, by default the file is created from scratch. It means that if the file already exists in your folder, it's going to be overwritten. Sometimes we may need to open an existing file, but we don't want to lose whatever it was in it. We don't want to overwrite on it. We want to add something at the end of it, or in other words, we want to append to it. So if you want to do that, C++ fstream class provides a solution for that. This is done by informing the C++ compiler about our intention to append to a file instead of overwriting it. So you can see that once you open a file, you can provide some guidance to the compiler that like, now I want to open this file for writing, but I don't want to overwrite on it. I don't want to lose whatever it was inside it already. I want to append to it. So this is gonna add the data that you want to write onto this file at the end of the file. So we have to be careful that this is gonna be written at the end of the file, at the end of the content. Like if you want to write something in the middle or in the beginning, this is not gonna work. Now, whatever you write to f out will be appended to the contents of the file. So you can see here, let's say like we already have a file named example output file.txt. Now that you want to append to it, these strings are gonna be added to whatever it was already in the file. Now, similarly, we can read from a file, read from a text file. Similar to OFS stream, we have a class called IFS stream. We can instantiate an object of this class. Again, we give our file has a name, so we have to, in this case, because we want to read it from a file, we have to be very careful to spell the file name very correctly. Otherwise, this operation will be unsuccessful. You basically make a connection between this object and the name of the file. Again, we have to check whether this operation was successful or not successful. If it was successful, it's gonna basically this is open member function is gonna return true. We're gonna read one string at a time. Okay, so we want to read one stream at a time, and we're gonna read it from the file here. Let me just like find the cursor. So we want to read it in the file, from the file. This is the name of the object, and we're gonna store it in the string line. And like here, I'm also like printing it so that you see like what was read from the file, and we closed it. Okay, so now one thing that you have to be careful is that when you want to read from a file, that file, when you read from it, every time you have input streaming from the file into your program, it would read only one string, and those strings are going to be separated by either space or tab or new line. So the delimiter for these strings are gonna be either space, tab, or new line, enter. Okay, so that's what's happening here. Now this operation might be unsuccessful. One reason for that is that like you don't have this file so in your folder, so you can't read from it. It might be in a different folder. Or you might make a typo here. There's a mismatch between the name of your file, so the compiler cannot find this file. So if that's unsuccessful, it's gonna print this message here. Okay, and every time you read from a file, it would just read one string from a file. And we have like the compiler has something like a file pointer that every time you read from a file, that pointer moves to the next string that has to be read. Okay, and it would move to the next one after you read that, and so on. So a position indicator is maintained by C++ for each file. Reading and writing will occur at this byte position. Indicator is automatically advanced by number of bytes read or written. Okay, so in this course, we only need to use the IFS stream, OFS stream objects. But this class also comes with other member functions that you can use. So if you want to read a whole line from your file, you can use the getLine member function. So this is example of that. So like it's shown like, again, like we are like opening the same file, but this time instead of just reading one string at a time, we want to read one line. So like here, it just basically checks like as long as there is a line to read, it would just read that line and print it on the screen and then close it. Okay, so get line can be used to read the whole line, no matter how many spaces we have in between. Okay, cin.getLine has the following prototype. So this is like how this function is defined uh, in the compiler. It assumes that S is an array of at least size characters. It reads in a single line of text from standard input and puts it into S as a C style string, which means that it is terminated by the null character. Okay. So this is gonna be a C string. The line is gonna be a C string. This part is only for your information. We're gonna be mainly focusing on reading one string at a time, like, and delimited by either space, tab, or new line. We can also open an input stream object and read data from a file to our program, as we already saw. Like, so you can use it like this. So using a default constructor and then opening the file, basically making this connection between this object and the file. Or you can combine these two and use the non-default constructor. So in this case, you don't need to open the file. It's just implicitly done in the non-default constructor. Then we can use fin together with the extraction operator, like this streaming operator, just like we do it with cin. For example, suppose there is a file named example input file.txt in the same folder where you had the cpp file. So this is like what we are gonna see next. Example input file. Suppose the file contains 5 integer numbers separated either by spaces, tabs, or each number on its own line. So that's what I mentioned. Like the delimiter, it's either space, tab, or new line. Then the following program will read the 5 numbers one by one using a loop and compute the minimum number and display it onto the screen. So here we instantiate this object, we associate it with the name of the file. We have two integer variables. We read the first number, okay, and as mentioned, there is a file pointer, there is an indicator that as soon as you read one element or one string from the file, it would move to the next one, it will move to the next one, it will move to the next one. So here you would read the next 4 numbers, right? And we wanted to find the minimum. That's why like one of them was done outside the loop, and it basically find the minimum number in the file and display it onto the screen. Extra attention needs to be paid when working with file input stream. Firstly, we should be certain that the physical file from which to read already exists. Otherwise, this operation would be unsuccessful. Okay. Secondly, we should know the type of the data in the file in order to read the proper data type variable. So like here we knew that it's going to be integer, so that's why like it was integer. Thirdly, we should make certain there is enough data in the file to read, right? So like here we assume that there are 5 numbers. If there were only 3, we would have problem, because then like you would get to a point that there is nothing to be read. So either we get an error or we get like garbage values. This is another example only for your information again. Again, I'm using the getLine function here. So here, this can be This example can be used to parse a text file. I'm sorry, I don't know why I do that. Again, we instantiate the object, we associate with the name of the text file. We make sure that this operation was successful. Okay, so if it wasn't successful, we just create a mess. We just like provide a message to the user and just return from the main function. Otherwise, we just keep reading from the file as long as this line means as long as there is something to read. So start reading from the text file and go all the way to the end of it. As long as there is something to read, just read it as a line, okay? And here we assume that the delimiter in the text file, so there was like a colon, so like in each line, so like we specify that, okay, find this, and just like this is gonna be the delimiter in every line. So just we would read the mark, and it just like, sorry, would read it from here, and then get, this is like a C command, so it would just read the next character, and if the file finishes, it would get out of the loop. Otherwise, it would print the string which was before the colon and the mark that was after the colon. Sorry, this I said character, I should have said string. Okay, so this is basically assuming that we had a file saying Alex colon 70, Bob colon 85, Kathy colon 80, and so on, and we wanted to change it to this format. This is how it is done. This part is only for your information, but like I just wanted you to see that like you can use getLine, and if you provide the delimiter in your file, you can just basically read up to this point. Okay, so like this means that we're only reading up to this point. So like in this case, we read Alex here, and here I'm also going to showing you like another function called get. It would read the next string that is supposed to read. So like if this was Alex, now 70 is here, it would just read 70. Recall that a file on disk is like an array of bytes, just as an array element can be accessed through an index value, one or more bytes can be directly accessed by giving the position of the starting byte. We're not going to focus on this part, but basically we can specify how many bytes we want to read as well. That's possible as well, but we're not going to go there. So to allow both file input and output in your program, you have to include the fs stream. And we can just like, we also like have to include use the namespace as standard. If you don't want to use the whole namespace, you can specify which classes you want to use. So in this case, you can say that I only want to use the ifs stream and ofs stream classes that are defined in the namespace standard. This is just a review of what we already have seen. So ofs stream, this is gonna create a stream to write to. ifs stream, a stream to read from. Okay, you like once you instantiate this object, you have to connect it to a file. As mentioned, these two lines can be merged together by saying ofs stream my output stream, open brackets, the name of the text file, close brackets, semicolon. The file names my out file or my in file refer to files that already exist for read or writing, or will be created for writing on your computer disk. Again, it's going to be created or read from the folder that your C++ program is in it. At least in Visual C++ it's like that. If input or output file are kept in the same folder as the executable then my out file.txt and my in file.txt will be the actual names of the files. However, if these files are in another folder, right, so you have to provide the full path of the file. So the full path of the file, something like this. Let's say like this file that we want to read from or write onto doesn't exist in the C++ folder. So like if you wanna, when you instantiate the object, you have to open it using the complete name of the file, including its path. So as a summary, like files will have two names in our program. One is the actual file name, the physical file name, right? Like my infile.txt, and the other name is the name of the object that we associated with this file. Okay, the that name is called stream name or logical file name. So we in this case here, the physical name is the stats.txt, the logical name is infile. Okay, both of them refer to the same file, but in our program we use the object name that we associated with this one. So as soon as we associated this physical name with this logical name, we can use the logical name, which is the object name, in our program. Some of this is just repeated to write data to your output stream. Eventually the data will go to my out file. Use this output streaming operator the same way that you use cout. So this is the name of the object that is associated with the file. It goes here, and whatever you want to write onto it, it's gonna go here. If you remember, cout is also an object. It's an object of class OSStream. So this is very similar to cout. And the same thing for cin. Cin was an object of class, is an object of class ISStream. Now instead of ISStream and ISStream and OSStream, we have FStream. Okay. And once you're done, you have to make sure once you're done with the file, you have to make sure to break the connection between the program and the file by closing it. Files automatically close when program ends, but make it a habit to close your files in the program, as in some systems and compilers you might have difficulty accessing the file that's not properly closed. So if you forget to close, in some systems you might not be able to open the file or save it or write something else onto it. So make it a habit to close your files. This is again emphasizes on specifying the path of the file if your file is going to be in a different folder other than your C++ file. As mentioned earlier, we have to check if the opening operation was successful or not successful for many reasons, like running out of memory, having typo and not reading the correct file, or the file doesn't exist or doesn't exist in the folder that we assume it exists. This operation might fail. So we used a member function called isOpen here to check that. There is another member function which is basically the opposite of that, just called fail. This is gonna return true if the opening operation was failed. So if this is failed, it means that the opening operation wasn't successful. So you can either use fout.fail or you can use not fout.isOpen. Both of them are the same. If this one returns true, this one returns false. If this one returns true, this one returns false. In the following example, we give a complete example to create a new file, write data on it, and then read the data from the file and print it to the screen. We also check the success of our file input output stream objects before we make use of the object. So you can see here, you open a file for writing, we check if this was successful or not. We write 10 random numbers onto it. We close the file. We open that file again. We check if the opening was successful. If it was successful, we're gonna read those 10 numbers from the file and display it onto the screen. This is like a useless program, but just wanted to show you how the OFS stream and IFS stream objects can basically read the file, and how the fail member function works, and like how these streaming operators work. So this is like, just it writes 10 numbers onto the file, close the file. This one is associated with this writing, and then opens the file again for reading, this time using IFS stream, read the data from it, and then close it again. So this is a very important example. This is a similar example to your class exercise. So assume that we have a text file like this, and so in each line we have 5 things: the first name, last name, and let's say like this is like, I don't know, like 3 different components of marks for a course. Let's say like quizzes, midterm, final. Okay, and what we want to do, we basically want to read this file. Okay, and so this is like, these, we assume that these data are stored in the class list.txt. We want to read all of these, and we want to write a C++ program that reads this file, and it should say class list.txt, and creates a new file named report.txt with the same content together with the letter grades of the students on the same line for each student. So for example, like we want to add these 3 numbers: 20 plus 19, it's going to be 39, plus 45, 84. Okay, so that's going to be the total mark, and we want to provide, okay, what's the letter grade? It's going to be letter grade B. So we want to do that in a different file. So we want to read from this file, but write onto this file. Okay, in this case, this can be done very simply. We open a file. You see that here we provided the full path of the file. We check if this was successful. We open a file for writing. This is the report file. Again, we check if this was successful. If it wasn't successful, we just like finish the program. And there are first name, last name, or here like exercise, project, final, and total. Total is like the summation of those 3 numbers. So for each of those 5 lines, we read 5 different things. These 2 are strings. These 3 are integer or double. So like it can be double or integer. And we calculate the total. Okay, we calculate the grade, the character grade. Okay, based on like the based on these ranges that is provided in the problem. Calculate if it's A, B, or C, or D, or F. And then on the other file that is associated with this object name fout, as you see here, we just write the first name, space, last name, tab, exercise, project, final. So like whatever it was already there. And we also add a grade at the end of it. Okay, so this is done for all the 5 lines, and once this is done, we are done reading, we are done writing, so we close both of them. Okay, now this is similar to the previous problem, But in this case, same example, but this time we don't want to write on a different file. We want to modify the same file. Okay, so in this case, you either have to use arrays or vectors or linked list or whatever. Why do we have to use arrays and or arrays or vectors? So here we could read from one file and write onto another file. But remember that you cannot read from a file and write onto it at the same time. In this case, this is not going to happen. Okay, if it's not going to provide the output or the result that we want, right? So we can't think about this. This is like I'm providing you the solution, but I want you to implement this yourself first. So in this case, we cannot read from this file and write something onto it, because you remember that when you want to write, it's gonna overwrite, so everything is gonna be gone. And if you want to append, it's gonna add something at the end of the file, not here. Okay, so we cannot use append either. So we cannot read and write from this file at the same time. What we have to do is to read from the file first, store all these values in a vector or in an array as it's done here. We calculate the grade, we close the opening, and then open the file now for writing. So here you see that like we open the file for input and then open the file for output. It's the same file, so I use like fstream and I specified like input or output. I could here say like ifstream f and ofstream something else, but it doesn't matter. Like I can just like use fstream and specify if it's done for input or output. So what's happening here, we open the file for reading, we check if the reading was successful, we read all the values and store it in an array of size 5. Okay, and the array that I created is an array of objects. To make it easier, in order to make it easier, instead of having like 5 different arrays, one or like 3 different arrays, or like actually 5, one for exercise, one for midterm, one for final, one for total, one for grade, one for first name, one for last name, so on. And instead of doing that, we had just one array of students, and this array this structure has how many, like 7 different member variables. Okay, and we just read everything, like we read the first name, then last name, test, midterm, final for a student 1, we calculate the total and the grade, and then it would read the second one, it would read the third one, it would read the fourth one, and so on. Once the reading is done, we close the function for reading, we open it for writing, and if it failed, like we provide a message to the user. If it didn't fail, we just like we basically transfer the content of our array or vector into the file. So you can see this here. This is very similar to the example that I gave you in the class. This is just another example, so you can think about like what's gonna happen in this case, and like what's missing, or like what's happening here. Another example from your textbook. These are like very basic, so I'm just gonna go over them, like we already covered them. As mentioned, like we have to check opening the file was successful or not. We can use either the fail member function or is_open member function for that. Some state flags that are gonna be helpful to use. So you already saw out, in an append, APP. Okay, and you also saw like fail, like if this was like not successful. One state flag that's gonna be very helpful is end of file. Okay, so here we wrote our program knowing exactly how many students we have in the file, right? That's why like we just like knew that like we have to go all the way to only 5 lines, right? What if we don't know how many lines we have in our text file? So there is a member function that would return true or false. It would return true if a file open for reading has reached the end. Okay, so if you reach the end, this would return true. So you can use this function to know exactly how many lines you have to read. Okay, so this is going to be very careful, very, very important, very useful for your example as well. So again, I want to emphasize that like this would return true when you reach the end of the file, when there's nothing else to be read. And why this is useful, because in most practical cases we don't know what's in the file, we don't know how many lines we have, we don't know how many students we have. Okay, to see more examples and to see more about these state flags, you can just like see this link provided here. This is like talking about appending. We already covered that. So like if you want to add content to the end of your file, you can append it, but like know that this is going to be added at the end of the file, not in the middle or not like in the beginning. The file modes that I already mentioned, some of them in, out, append. There are other modes that we can use, but this is only for your information. We're not going to cover that. And we can just combine different modes together using a bar symbol, but like we don't need to worry about that. So the last example, I guess, this is just like an example that read from a file and write onto another file. Okay, we just make sure that like both of the files were open, and as long as there is something to be read, we just read from it and write it onto the other one. And just like I think it just like it also replaced the hello with goodbye. So like if the string that you read is hello, it's gonna replace it with goodbye. This is an example that you can check. These are some assignments that I gave to my CMPT 135 students. You can think about it if you are interested in like learning more or coding more. So like a bonus assignment is basically, you know that like when you write a C++ program in Visual C++, if you format selection, it would indent the file automatically for you. Okay, so you see that like it would provide indentation. Now what I want you to do as a bonus assignment, if you have time, if you don't have time, don't worry about it, you already have enough quizzes and assignments. But if you're like interested in learning more about programming, so like maybe you can write your own function that takes a text file, which is gonna be a C++ program, but it might not be indented. Okay, and you have to make sure that when your program is run, that file is gonna be indented. It's not a very easy program, it's not a very easy task. That's why like it's not mandatory. So another bonus assignment that I gave to my CMPT 135 students was just provide like a phone book, or like create a phone book and provide different options for sorting based on name, based on the ID, based on the phone number, inserting a name into this file, deleting a name from this file. So like this is another bonus assignment that I gave to my CMPT 135 students. Like this is only for your information. You don't have to do any of them. Thank you so much. I hope this was helpful.